Hey, welcome back to another exciting adventure of Mr. Wernau Does Your Homework. Alright, so we're going to be taking a look at some arc trig problems, derivatives and antiderivatives. So for like the first few, we're going to take a look at a bunch of derivatives. So we have the function f of x equals 3 arc sine of 5x. And we're asked to find the derivative. Well, arc sine, if you might remember, becomes this. It's just 1 over the square root of 1 minus x squared. Of course, that's going to be our x right there. Now, there is a chain rule here because of the 5x. So, when we take the derivative, we're going to get f prime of x equals 3 times 1 over, and this becomes the square root of 1 plus 5x squared, so 25x squared times. There is a chain rule part here, so don't forget that. We multiply that by 5, and you can simplify this by making it 15 over the square root of 1 plus 25x squared. If we want to do arc secant, well, remember arc secant, this one, when you look at the answer, this is going to be our 1 over the absolute value of x times the square root of x squared minus 1. Remember, it's absolute value. Looking at another video, that's because this is a radius. It's our hypotenuse of our right triangle. So it always has to be positive. So our derivative, g prime of x, would become 1 over the absolute value of, that's my x, 3x times the square root of 9x squared minus 1. There is again a chain rule. Don't forget that. So I'll multiply that by 3. And of course, you can cancel those 3's even if it's in the absolute value, and we would get 1 over the absolute value of x times the square root of 9x squared minus 1. And there's our derivative. Very easy to do. All right, number 5. Let's take a look at another one. Oh no, in this case right here, if you do notice, we do have our arc sine, which we saw the rule up here. But notice we're also dividing by x. This is our quotient rule. So we're going to take the derivative, dy dx is low, times the derivative of the top, which is 1 over the square root of 1 minus x squared, so 4x squared times, chain rule, 2 minus the top, arc sine of 2x times the derivative of the bottom, all over the bottom squared. Alright, this is pretty darn nasty, so we're going to multiply by our common denominator, which in this case is actually going to be our radical, the square root of 1 minus 4x squared. The square root of 1 minus 4x squared is my denominator. And if we do that, we're going to get 2x minus the arc sine of 2x times the square root of 1 minus 4x squared divided by x squared times the squared 1 minus 4x squared. And you can leave it like this if you like. Easy to do. You can split that up. Now remember, the reason why we multiply by here is because if I were to rewrite this, we would get 2x over the square root of 1 minus 4x squared minus the arc sine of 2x over x squared. So we would just multiply everything by that denominator right here. Alright, hope you guys are doing good so far. I think we're on a good path right here. So let's see here. Now we want to do the arc secant of the tangent of x. So the secant of the arc tangent of x. Alright, there's a couple ways you can do this. You could use chain rule for something like this. But, you know, I'm going to be fancy. I'm going to use my right triangles. So I'm looking at the arc tangent of x. So if I were to draw a function here, and there's theta, right? Arc tangent is the tangent is the opposite over the adjacent, which is going to give me the hypotenuse of 1 plus x squared. Well, from pre-cal, I now know that the secant, I want the secant of theta. So the secant of theta is the hypotenuse over the adjacent. So the secant of theta is just 1 plus x squared. So therefore, we can really say q of x is just the square root of 1 plus x squared. And if we take the derivative, q prime of x, this is just 1 plus x squared to the 1/2, we would get 1/2 1 plus x squared to the negative 1/2 times 2x. And that the 2's here will cancel, and we can just say that this is just x over the square root of 1 plus x squared. And there is our derivative. So we can do that with all sorts of little problems. Like what if I did something like, if I said y is equal to the tangent of the arc cosine of x. Well, if I look at the arc cosine of x, if this is theta, cosine is the adjacent over the hypotenuse, so this is going to be x squared minus 1. So tangent of theta, just like in pre-cal, is going to be the opposite over the adjacent. Square root of x squared minus 1. And this is what y is equal to. So the derivative, well, this is just product, chain rule. We get 1/2 x squared minus 1 to the negative 1/2 times 2x. And of course you can clean that up. Good problems to know how to do. They're a lot of fun to do. Alright, that's about video number 1. Go to video number 2. We're going to take a look at some antiderivatives. I will see you then.